Alright, welcome back for part 3 of 3, IP version 4 subnetting, in this case subnetting for a specific number of networks. Now again, in part 1 we did a basic overview of what the IP version 4 subnet mask is there to do. Part 2 we looked at subnetting specifically to find a certain number of hosts, and in this case we're going to do subnetting again, but to find a specific number of networks. Now, you might want to subnet for a specific number of networks just to determine if I've got a certain number of floors, a certain number of departments that I each want to have a specific network for. At this point, I might not care about the total number of hosts per network. I just want to find out exactly how many networks I need IP addresses for, so we can subnet for a specific number of networks in general. Now again, we're going to do a very basic overview of class A, B, and C and take a look at a couple of examples, and you'll see if you watched part 2, subnetting for a specific number of hosts, subnetting for a specific number of networks is virtually identical. There's just one minor change when you start figuring out your subnet mask. So again, default, class A, B, and C. Class A, first octet, 1 through 126, always means you're on a class A, default mask, 255.0.0.0. Class B, first octet will always start with 128 through 191, default mask 255.255.0.0. Class C, first octet range 192 through 223, default mask 255.255.255.0. And again, that's important because your default masks are always your starting point, so you can figure out how many bits you need to add to your subnet mask. So, take a look at example number 1, jump right into it. Subnet, I want to have at least 12 networks when starting out again with a standard Class C subnet mask. So my current subnet is 192.168.10.0. 192 is a Class C address space, so my default subnet mask is 255.255.255.0. Now, when I break this down into binary, you'll again see the first 3 octets, 255.255.255.0, all ones. My last octet, being all zeros, is the one that I can play with. Now again, when looking at a subnet mask, anything that's marked as a 1 is part of your subnet, so these are your subnet bits. Anything that's a 0 are for your hosts, so these are host bits. Now when I break these down and start looking at the bits with their decimal representation, you'll see the 128 down to the 1. If I add all these up, I will in fact get 255. But in this case, I'm not looking for 255. I'm looking to find exactly how many need to represent 12 networks. So I need to mark off the ones that will give me the number I'm looking for, in this case 12. Magically enough, 8 and 4, when I add those up, do in fact give me 12, which means the total number of bits I need to represent 12 networks is 4. 2 ones and 2 zeros in this case, so 1, 2, 3, 4 bits. This means that I need to add 4 bits to my subnet mask. Now previously when subnetting for hosts, when you'd figure out these bits, those were the number of bits that you'd reserve for hosts. But we're not figuring out for hosts here, I'm figuring out for a specific number of networks. So now these are the bits that I need to add to my existing subnet mask. So essentially what I'm going to be doing here is extending my subnet mask by 4 bits. So when I look at this now, in binary, my new subnet mask is going to be 8 bits in the first octet, 8 bits in the second, 8 bits in the third, just as what we started with, and now 4 bits in the fourth octet, because I was extending my subnet mask by 4 bits. So I've got 255.255.255 dot something. And again, to figure this out, just like you probably saw in part 2, break it down into decimal representation again, and I've got these first 4 bits that I'm marking off. So the 128, 64, 32, and 16. When I add those up, I get a final number of 240. So my final subnet mask is 255.255.255.240. Or, again, if you want to go with slash notation, a slash 28, because I've got 8 bits, 8 bits, 8 bits, and 4 bits. 8 plus 8 plus 8 plus 4 gives me a total of slash 28. So it's the same thing as writing all this out. Now, we need to figure out what exactly the new network IDs are when using 240 as a subnet mask. So again, just like we did in the last section, 256 minus 240 gives me the number 16. This tells me that my network IDs now are incrementing by 16s. So the new network IDs that are created here, the original one that I started out with, 192.168.10.0. The next one, new one, would be 192.168.10.16, followed by 10.32, 10.48, 10.64, 10.80, 10.96, so on and so forth. To figure out then the ranges of addresses, you'll see it's exactly the same as the previous section. We do a +1 -2. So my first available network address on the 10.0 network would be 10.1, because again, 10.0 is a network ID. I can't assign this to a host, so the first available address is 10.1. 10.16 is my next network ID, so I count back 2 from there. Again, 10.16 is a network ID. I can't assign that to a host, and the very last address in each range is the broadcast address. So in this case, 10.15 would be the broadcast address, which leaves me with the last available IP address of 10.14. When I want to find the address range of the 16 network, it would be 16 plus 1 and the next available network ID of 10.32 minus 2. So my network range, 10.17 through 10.30. When I want to figure out for the 32 network, we do 32 plus 1 and 48, which is the next network ID, minus 2, which would give me 33 through 46. So, as you can see, extremely similar to subnetting for hosts. The only difference is what you do with the bits when you figure out how many that you need. So, looking at another example, in this case here I want 6 networks. We're starting out with the same network ID initially of 192.168.10.0. It is Class C, which starts me out with 255.255.255.0. Now when I break this out again into binary, you see the same thing. You see 24 bits followed by 8 zeros at the end. Here's their decimal representation. I want to figure out what I need to give me, in this case, 6. Pretty basic. 4 plus 2 gives me 6, which means I need 3 total bits, the 1, the 1, and the 0, that I'm going to have to add to my subnet mask to represent 6 new networks. So when I look at this, my new subnet mask is going to be 8 ones in the first octet, 8 in the second, 8 in the third, and then the 3 ones that I want to add in the fourth octet. So this is going to give me 255.255.255 dot something. When I look at the decimal representation, 128, 64, and 32, the first 3 bits are the ones that we added to my subnet mask. When I add those up, I get 224. So my next my subnet mask now that I've created is 255.255.255.224, or again, if you want to, represent it as a /27, 8 bits, 8 bits, 8 bits, and 3 bits, so 24 plus 3 gives me a total of a /27. Figuring out my network IDs, 256 minus the number we figured out for my subnet mask, which is 224, gives me the number 32. This tells me again my network IDs are incrementing by 32. So my first available network ID is 10.0, the one we started out with, followed by 10.32, 10.64, 10.96. These are all the network IDs that are defining the different hosts on my network. Address ranges, in this case for the 10.0 network, again we do a +1 and a -2, so it would be 10.1, and the next network ID in this case is 32, so 32 minus 2 gives me an address range of 10.1 through 10.30. Looking at the 32 network, 64 would be the next available network address, so it would be 32 plus 1, which would give me a first available address of 10.33. 10.64 minus 2 would give me a last available address of 10.62. So my overall address range on the 32 network would be 10.33 through 10.62. Looking at the 64 network, again, we do a +1 -2. So the 10.64, again, network ID, can't use it. So we add 1, gives me an address range, or the first available address in this range of 10.65. 10.96 is the next network ID, so we -2 from that, which gives me a final available address on the 64 network of 10.94. Number 3. Now again, we're going to look at a Class B address space to give you a basic idea of the difference here, which again gives me a lot more bits to work with rather than 8 bits to play with. I now have 16 total bits, so I can deal with a lot more or larger problems to deal with. So in this case, rather than 6 or 12, now I want to have 650 new available networks to me. Now the default Class B subnet mask, 255.255.0.0, which when we look at this gives me the ability of playing with, again, 16 total bits. Now I'm looking for, in this case, 650. So just like before, we need to add up the bits that give me the number I want, in this case, 650. So we take a look at this. The 512, 128, 8, and 2 actually equal up total of 650, which means to represent and actually have 650 new networks, I need to add 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 total bits to my existing subnet mask. So right now my subnet mask has 16 bits in it. I need to extend it by 10, add 10 new bits to that subnet mask. When we do this, you'll see that we have now the original 16 bits. The first two octets were always 8 bits. Now I added 10. Now obviously there's only 8 bits per octet, so I filled up the third octet, that's 8 bits, and then I overflowed to the fourth octet a little bit. These are the final two. The 8 bits in the third octet and the 2 bits in the fourth octet are the 10 bits that I added to my subnet mask. So my new subnet mask is going to be 255.255.255 dot something. And again, to figure out what that fourth octet equals, look at the decimal conversion table of 128 down to 1. We're using the first 2 bits here, so 128 and the 64. Add up the 128 and the 64, you get 192. So my total overall subnet mask now will be 255.255.255.192, or, again, if you want to, a /26. To figure out the address ranges here, take the 256, subtract 192, which is the oddball number in my subnet mask, and I get a total of 64. So my network IDs are now incrementing by 64. So my network IDs, first off, I started out with 171.109.00. And it's the 64, the 192 that we subtracted from 256 came from the fourth octet. So it's the fourth octet that's going to be incrementing by 64s. So my next available network ID is 171.109.0.64, followed by 0.128, 0.192. Now, this is not obviously where it stops. We're dealing with a much larger address range. So what will actually happen here is this is going to roll over, and the next available network ID is 172.109.1.0, then 1.64, 1.128, 1.92, then 2.0, 2.64, 2.128, 2.192, 3.0, so on and so forth until you get to your final network ID, which is going to be 255.192. A lot of networks in between there, here and there. So to figure out the address ranges, again, very simple. We do the +1 - 2. The very first network ID, 171.109.0.0. We add 1 to it, which gives me a very first available address of 0.1. The next network ID is 0.64. Subtract 2 from that fourth octet. Leaves me with a final available address of 0.62. On the next network ID of 0.64, the ID after that would be, the network ID after that is 0.128. So figuring out the ranges of addresses, do a +1 to the 64, a -2 to the 128, gives me an address range of 0.65 through 0.126. When figuring out for the 128 network, 192 is the next available network ID. So we add 1 to the 128, we subtract 2 from the 192, gives me an address range of 0.129 through 0.190. Looking at the last one, 0.192. Again, 1.0 is the next address range because we're incrementing by 64s, and if you take 64 and add it to 192, you get 256. But you can't actually have the number 256 inside this octet. It's 255 is the highest you can go. So 0.256 technically doesn't exist, but 1.0 does. So 256 doesn't happen. What actually happens is the 192 turns into a 0, the 0 rolls over to a 1, and you just start over again. So my next available network ID is 1.0. When we look at this, we do the 192 + 1, which gives me the 0.193 is the first available address, and then count back 2 from 1.0, which would give me 0.254, because the broadcast address here would be 0.255. So the last available address on this network would be 0.254. Now, again, this is a pretty quick and dirty way of looking at some of the subnetting stuff, and again, mainly for Microsoft testing. Hopefully this will give you some of the steps that you can look at, something you can reference back to when you're reviewing something in terms of how some of this can be done. There's dozens of different ways of subnetting. This is one of the easiest ways that I find to explain to people, especially when we're in class. So if you are actually going to be in class, and I'm going to be there, this is the way that I explain it. If you have your own way of doing it, feel free to stick with it. When you figure this out and you're happy with it, that's all that matters, is you get the right answer. Some people like dealing with exponents, some people like memorizing charts. Everybody's a little bit different when it comes down to it. However, usually when dealing in class, this, like I said, is pretty much one of the easier ways of looking at it. So hope this helped out a little bit, and if I'm going to see you in class, you can ask me questions about it then, and we'll have a lot more fun with it at that point. So thanks for listening, and I'll talk to you later.